here we are. So firstly, I'd like to thank Mark and to the SPRITE Plus management team for supporting my application for a secondment grant to pursue a piece of research with British Telecoms. So basically, the title of this project is an AI-based approach for detecting advanced persistent threats in large networks. And it's a collaboration with some of the folks at BT Security, primarily based at BT in Belfast. So the outline of my presentation is as follows. First, I will begin by highlighting the key points from a research paper that was recently accepted and published in Computers and Security. The reason for actually doing this is because this paper actually served as a discussion point prior to me starting my secondment, which then actually led to BT's engineers, suggesting how the approach that I developed can be modified to make it more useful to industry. And then I will conclude with some of the ongoing and future research with British Telecoms. Right, so this is the paper. As I mentioned, it was accepted for publication in CUSE in May 2025, and the authors are myself, Arshad, and Adinayesh, and that's the DOI. So the research question is essentially to ascertain if deep learning models can predict reflection attacks in net flow data. So I'll first begin by talking about what is actually a reflection attack. So you have heard of massive disruption to services, etc., especially for e-commerce websites, and not just e-commerce websites, but also, various other services as well, especially pertaining to the internet. And reflection attacks is a special type of DDoS that is a lot more trickier to actually detect and predict because it hides the identity of the attacker by using and it uses reflectors to amplify malicious network traffic. So these reflectors are essentially based on the same network protocol, and it actually uses the same servers, the same system to actually attack the same system. So network protocols such as DNS, the network time protocol, NetBIOS, etc., are especially vulnerable to reflection attacks. So firstly, what is the novelty of this work and the contributions? So we have got a lot of network detection schemes, but one of the things about network prediction schemes is lie in their ability to identify and attack in advance. So if you're able to identify the source, and the times in which, an impending attack is about to occur, then the security analysts would have more time to respond to the attack more effectively. And prior to this, there's actually no work that evaluated basically a number of state-of-the-art deep learning models to predict reflection attacks in a large network. So here the contributions are, we proposed an approach to predict reflection attacks, we validated the approach on real net flow data, and we applied a model validation step to ensure that the results are accurate. So this is basically a outline, a workflow of the deep learning based approach. It actually comprises of 3 modules here. And basically what I'll do is that I'll go on to the next part, which is about the data that actually I analyzed. So it's 2 weeks worth of net flow data that contains about 3.1 billion net flow records. So this data actually contains devices that were actually compromised, but the data is essentially unlabeled. So essentially, one has to actually apply some expert knowledge in order to actually figure out which records corresponds to a potential suspicious activity, or is it a benign activity. So I was actually able to identify a small number of records that appears to be associated with reflection attacks on the DNS and NetBIOS servers. And the results are as follows. For the DNS reflection attack, one of the things is that we actually learned that while the 3 deep learning models were able to predict majority of the attacks on most of the days, there were 2 dates where basically none of the 3 models were able to predict DNS reflection attacks. In contrast, for NetBIOS, the RNN, LSTM, and TCN actually predicted these attacks with very high accuracy on all 14 days. That's 2 weeks of the data. So here we got some traffic, analyzing some of the traffic generated by those attacks. And one of the things that we observe in the data is that these attacks, while they actually did occur, or they seem to actually occur, the percentage of packets that were generated is actually not sufficient to actually overwhelm the network. Ditto for the DNS protocol. So when I actually started the secondment in April this year, one of the issues that BT engineers actually pointed out to me was the utility of the approach. Machine learning tends to focus a lot on model validation, but here they actually come from a perspective of false positives in the data. And this is actually a very different perspective, which actually I found it really useful, because from days, BT and I, we are currently writing a new journal paper, to actually point out these issues, and develop, an ensemble learning framework to try to detect these malicious events. So here we have an issue that a network record that corresponds to a legitimate communication between two network devices that use the same port. Those network records could actually represent a legitimate communication between two network devices, or it can actually represent an exploit of a well-known network service. So we look at 5 days of data, and we identified, okay, there were like a small percentage of net flow records that actually contains the same network ports. And these discussions with BT, we decided to focus on port 123, which is the network time protocol, because it is a widely used protocol for synchronizing the clocks of computers on the network. And it is also widely used in several other widely used network protocols such as DNS, Microsoft Active Directory, and NTP is vulnerable to both DDoS as well as reflection attacks. And one of the things that BT guys actually pointed out is that the determining if a network record that contains NTP communication cases, there are several corner cases to actually look out for. Hence, we focus on port 123. So the first corner case pertains to Microsoft Active Directory. So in the NTP protocol, the protocol states that for a computer device to synchronize its clock with a network time server, one packet is actually sent from the client to the NTP server, and the NTP server will then return one packet back to the client. So this is what the NTP standard protocol says that it should be. So when I actually look further into the NetFlow records, we actually found that it contains multi-packet responses from the NTP servers back to the client. Now, this actually seems to suggest that this might be a prelude to a reflection attack. But we also notice that the start times, that these events occur at the start of the day. What this means is that this, while it seems to appear that it's a suspicious event, it might be the case that this is actually a network administrator performing a clock synchronization of all their client devices on their network. Hence, the start time in this NetFlow records, it's actually basically very close to the start of the day itself. A second corner case is when two devices are synchronizing their clocks, because sometimes devices, they have certain automated clock synchronization functions that is executed that is designed or configured to execute periodically. And these also eventually could actually result in multi-packet responses being returned from the time server back to the client. So we just found that this is actually potentially another corner case. So it's actually what happens here is that while these NetFlow records appear to suggest that a reflection attack might be occurring, in contrast, it could also actually indicate that this might be actually a standard event, leading myself and the BT guys to basically, suggest that basically to conclude that if we only have a certain limited number of features, then we cannot conclusively say that this is actually an actual malicious attack on the network. However, BT also provided another suggestion that this could be actually an APT threat actor already in the network. And these threat actors could be living off the land by basically consuming resources of the network and waiting for the right time to actually execute a reflection DDoS. So the ongoing research currently is that together with BT, we have developed an approach that uses an ensemble of regularized regression models. And we are actually writing up the approach, results, and discussion in a joint paper that we plan to submit to a good cybersecurity journal. The results currently looks very promising. And for future research, basically in collaboration with BT security engineers, we actually plan to investigate, other well-known network protocols to identify, certain more corner cases, in particular DNS, SSH, SSDP, etc. And also to investigate machine learning and deep learning model ensembles to increase the prediction accuracy. As we've seen in some of the results before, there were some dates, where individual deep learning models were unable to predict reflection attacks with a very high R squared.